right, so what we're going to be doing today is writing the equation of lines. We've done that before in algebra, so just writing it. I'm going to show you a different form rather than just slope-intercept, and I think some of you will like it. We need to convert between the forms, and we did some classifying yesterday. Right? How can you tell whether two lines are perpendicular? What information would help you know whether two lines are perpendicular? Lucas? Okay, and how can you tell that from the information about a line? Would the y-intercept tell you whether they intersect at a 90-degree angle? What's going to tell us whether they intersect at a 90-degree angle? Okay, the slopes. If the slopes are opposite reciprocals, correct. So that was in yesterday's. What about the slopes to be parallel lines? Yes? Parallel lines, what about their slopes? Correct. Same slope, different y-intercepts. What if they have same slope and same y-intercept? Coinciding. Okay. And then we got intersecting. How can you tell if they're going to intersect? Yesterday, two lines intersect. Right. Just if the slopes are different in any way, they don't have to be the opposite reciprocals to intersect. They just have to be different. If they are different and they are those opposite reciprocals, then they intersect at a 90-degree angle. So those were some things from yesterday. Okay. Today we're going to again talk about those forms. I showed you this slide yesterday. There's standard form, slope-intercept form, and point-slope form. The standard form, I don't think I have anything in your notes. You might just put that on your 3-6 page, just a little bit about what standard form is. Standard form for an equation of a line is ax plus by equals c. So for example, 3x plus 2y equals 12. That's the equation that we graph to be a line, but it's called standard form. And the reason we have standard form, I mentioned yesterday, is vertical lines you can write in standard form because it doesn't specifically require you to put a number in for the slope. Slope of vertical lines is undefined, so that causes problems in our other two forms. Standard form, I will probably give you some problems in standard form, but you're typically going to take that and convert it into a different form so that we can use information to analyze. So we won't be using standard form a lot, except me giving you problems in that form. We're going to be using point-slope form today. I don't think you got notes on that yesterday. If you did, maybe you had your notes in the wrong place. Okay, point-slope form, we're on section 3.6, up way at the top. Point-slope form is another way to write the equation of a line. It would if you're looking at an equation in point-slope form, you're going to be able to tell a point it goes through and the slope that it has. The point that it goes through is not necessarily the y-intercept. It could be, but more often it's not. So in your notation part, m is still going to be the slope. The x1 and the y1 are the coordinates of one point that that line has to go through. Any point that it goes through can be used to come up with the equation. So your example over here, the 2 is the slope. The point that it would have to go through is 4, 3. Where do I get the 4, 3? Right here and here. It's not that it's -4 and -3, so I guess you have to get used to that. It's like the opposite of what you see there. Now if I were to graph that line, I can graph it from this information. Goes through the point 4, 3. And then from there, a slope of 2. Let's make it a fraction, so we have a rise and a run. So go up 2 to the right 1, up 2 to the right 1. You can graph the equation of the line from point-slope form. It's just that the point you start at is not right on the y-axis, but it is a point that's going to be on that line. So you can do some graphing from it. All right, point slope is the one that I'm going to focus on today. So let's see if you can give yourself a real example. Write the equation of the line that goes through the point 8, negative 5. It has to have a slope of negative 1/2. I want you just to write it in point slope form. So this would be another example of point slope form. Insert the point it has to go through in the right places. Insert the slope it has to go through. And there's usually not a lot of simplifying that we do. So we get in point slope. Yes. It's called point slope. What's the point it needs to go through? 8, negative 5. So the 8 is what in my equation? The x1, and the negative 5 will be the y1. So that's going to look like x minus 8 and y minus negative 5. The slope is negative 1/2. It says keep it in point slope form. Let's make an agreement that we do simplify minus negatives to plus positive. So our equation is going to say y plus 5 equals negative 1/2, parentheses, x minus 8. That's the equation in point slope form. You can tell the point that it has to go through and the slope it needs to have. And we'll take that in our lesson today and convert it into slope-intercept. Everyone got what they need from that sample? Point slope will typically have these parentheses left in it. If you're doing something to simplify it, to get rid of the parentheses, you're putting it in a different form. And we're going to try and go back and forth. Got it? Okay. Now from yesterday, you should have information about slope-intercept form. So look at your notes and write the equation of a line with slope of negative 5 and a y-intercept of negative 3. For slope-intercept form, what would that look like? What information do you put into that equation? You put in the slope and you put in the y-intercept. I told you both of them. Grant, what did you write down? Y equals negative 5x minus 3. So the correct form, if you have the right information, it's really easy to do. Okay, and did you get from yesterday your horizontal and vertical lines? I think we did that yesterday, and I think we even did that same example. So we'll go through that. All right, so here's what I want us to accomplish today. Write the equation of the line with slope of 3/4 through the point 4/6, and I want you to finish in slope-intercept form. And notice that if we're using slope-intercept form, I did give you the slope, 3/4, is 4/6 the intercept. Isn't the y-intercept supposed to be on the y-axis? Where would the point 4/6 be? Is it on the y-axis? Notice it's not. It would be 4 to the right and 6 up. So I can't directly do slope-intercept form with the information I have. So here's what I want to suggest that you do. A lot of you have struggled with that worksheet that we did a couple weeks ago to try and write the equation of the line. Let's start with point slope form because we have a point and the slope that it needs to have let's start with that and then turn it into slope-intercept. So for this example, let's start with slope-intercept. So put in the slope, 3/4. Put in the 4/6 as the x1, y1. You're substituting right now. Now if we want to finish in slope-intercept, we just need to do what you did on the bell ringer. Simplify this. Get it to say y equals like mx plus b. So distribute the 3/4. Figure out what 3/4 times that minus 4 is. And bring that 6 over. What was 3/4 times the minus 4? Is that 3? Or minus 3, I guess. And then you add 6 to each side to get y equals 3/4 x plus 3. Thumbs up or down? Did you get it? Grant, did you get there? Isn't it? How about over here? Get it? Okay, so we ended up in slope-intercept form, but we started with point-slope form. Why did we start with that? Because that's the information we had. And this is a different method than what you learned in Algebra 1. I think it's going to be a method that you can do easily, rather than substitute in, find the b, and then rewrite it. So that's what we're trying. Okay, let's try another one. Write the equation. What's the 2/3? Again, the place we're getting stuck is distributing right here. 2/3 times x, 2/3 x. 2/3 times 6. Okay, let's go over here. 2/3 times 6 over 1. Even if you don't reduce, 12/3, which is 4. So when I distribute that part, it should say plus 4. Then to get it into slope-intercept, the only thing you have to do now is move this 12. So to move it, add 12 to each side, put it with what you can. So you should have y equals 2/3 x plus 16. Did I do that right? Figure out if you did a sign wrong or something maybe. Okay, question? Okay. There's the rest. All right, write the equation of the line through that point and that point in slope-intercept form. So what did I do different on this one? I didn't give you the slope, but I gave you 2 points. For point-slope form, you could use whichever one you want, but how do we find the slope? We did that. Which formula? The third one down. Okay, and if you need a reminder, put that in your notes. So calculate the slope first. Find the slope. y2 minus y1 over x2 minus x1. If you're running out of room on your notes paper, grab your own sheet of paper so that you can keep writing down examples. There were 2 for the slope. All right, if you've got 1/2, you're doing it upside down. If you have a negative on there, you're switching the order when you subtract. Okay, now finish writing the equation. You just found the slope, And out of those 2 points, pick whichever one looks like your favorite. I don't care which one. Pick one of them to use for your point. Whatever. Write the equation now with that slope and that point. So start with point slope. Fill in what you just found. Then convert it into slope intercept. If someone uses the other point, then we can check and see if it makes any difference which one you use. Okay, what are you coming up with? 2x minus 3. Right? Is the 2x right? And not the minus 3? If someone check with, did you distribute? Distributed, right? Okay, what do you have, Ben?
Y equals 2x plus 1.
Is he right? Still not right? Okay. What's it supposed to be? Let's see. I guess in my sample I used the other one. Did you use the 1, 4 as the point? No? You used the 0, the negative 1, 0? Okay, negative 1, 0. So he tried this other one. Let's see what happened here. Okay, simplify. Where did I get my plus? Change the minus negative, and notice y minus 0 is just y. Distribute 2x plus 2. You're done. I don't know where you got your 3 or your 1. All right, now if I circled the other point, but using it in here, do we still get 2x plus 2? Distributed correctly? All right, so we're doing some issues or some problems with the distributing part. We know what to do, we're just not doing it right. Okay. Okay, for the slope, I don't know which order you went, but here's one of the y's, subtract the other y, and in the same order, the x from here minus the other x, minus negative is plus positive, so I'm getting negative 4 over negative 2. Negative divided by negative is positive, and 4 divided by 2 is 2. So now I'm going to plug into the point slope form. Which is your favorite point, Grant?
7, 8.
Okay, so 7 and then negative 2. It's going to look like that. And put in the 2 for the slope. Let's change this minus negative to plus positive. Distribute. So y plus 2 equals 2x minus 14. Subtract 2. Did I do it right? Y equals 2x minus 16. Yes or no? Yep, okay. How many got that right before I did? Jake didn't get it right? You did? Andrew? Did you? You had a 6. Okay, did you distribute and get a minus 14 right there? Did you use the 0.5 negative 6 by chance? Okay, so let's see what happens if you used 5 negative 6. He would have y minus negative 6 over here, 2 and x minus 5. Okay, so when he distributes, yeah, he's not going to get the same numbers that I had. He's going to have 2x minus 10 right there. Over here simplifies to y plus 6. Now subtract 6 to bring it over. Y equals 2x minus 16. Should be the same solution in the end. Okay. Now our next step is we're going to do parallel and perpendicular equations. So let's review again. What's the relationship for the slope of parallel lines? They're equal. And the slope of perpendicular lines, opposite sign and reciprocal. So you have to change the sign and flip it over. Okay, they would multiply to be -1. So here's our next type of equation. Write the equation of the line parallel to y equals -3x plus 6, but it has to go through the point 1, -5. I want it in slope-intercept form in the end, but I don't think that's what I'm gonna start with because I don't know what intercept the new line's gonna have. I know the intercept for the old one, but parallel lines, what did we say the relationship is from yesterday? Parallel lines, the equations would have same slope, different y-intercepts. So the equation that we're going to write will not have this y-intercept. It's gonna have a different one. We need to figure out what it is, and we can do that by writing the equation. So what's the slope I need to have? The slope of this one is -3. To write the equation of a line parallel, do I want -3 for the slope of the parallel line? No? What did we just say on that last screen? Or remind ourselves, parallel lines have same slope. So yes, we do want that. Okay? The slope is -3, a parallel line will have the slope of -3 also. What point do we want it to go through? 1, -5. So here's your information to write the equation. You've been writing the equation, so come up with the equation. The slope has to be -3. The point it goes. Yeah. Agree with her? Yeah. Okay. So what I want you to notice is from yesterday, if we compare this line's equation and the original line's equation, are they parallel? Do they have the same slope and different y-intercepts? So notice that they would indicate parallel based upon what we were doing yesterday. All right. Next example. Show my step-by-step behind here. Yeah, so what'd you get?
Y equals 1/5 x minus 5.
Agreed or not? Yeah. Okay. Oh, I don't remember what I got. That's the right thing. Yeah. How many got it right? Okay, quite a few. Question? Could you, Doug? Did you just distribute wrong?
Yeah.
Okay, so this number here is what's causing you problems. Getting that right number. Multiplying to distribute. Well, they finished looking at that one. I think our next example, instead of asking you for the line parallel, I'm going to switch it to perpendicular. So what's going to change? The slope that we pick. Right. We don't want the same slope to make it a perpendicular. We want opposite sign and reciprocal. So we're going to have to read carefully on the next one. All right, so next example. I want you to write the equation of the line perpendicular to the one I start you with. It has to go through the point 9, -5. We'll end up in slope-intercept form. So the slope of the one I gave you was -3. What's the perpendicular line's slope need to be? The same? No, opposite sign and reciprocal. So what would that be? 1/3? Correct. And if you're not sure, make that a fraction so you can see flipping it over and changing its sign. So there's the slope we want. The point it needs to go through was 9, -5. Write the equation of the line with that information.
Y equals 1/3 x minus 8.
That's what I was seeing up in the front. And I got that one right. Okay, thank you. Question, Grant? Okay. All right. one more before we do the last type for today. What slope should you be using? Negative 3/5, not positive 3/5. Negative 3/5. Let's see. Tell me if I did this right. I kind of quickly did it before lunch. Was it negative 3/5 x minus 11? Yeah, okay. So comparing this equation and the one I started with, the slopes are different, so they'll intersect, and they're opposite reciprocals. They would intersect at a 90-degree angle. Okay, so we wrote equations, we did parallels, we did perpendiculars. The last bit is from the 3-4 section. So flip to the 3-4. Okay, 3-4 is about perpendicular bisectors. Okay, a perpendicular bisector is a line that forms a right angle with a segment and goes through the segment's midpoint. So draw yourself just a little picture by that definition. A perpendicular bisector of a segment is a line forming a right angle with the segment at the segment's midpoint. So if your segment is AB, this has to be the midpoint, and it has to make a 90-degree angle. Now we're actually going to construct the perpendicular bisector. Okay. Okay. So there's an extra step in here. So I'm going to skip the graphing part. So let's try and write the equation of this perpendicular bisector. Okay, so AB is the point -1, -3, and slope of AB. Okay, so I'm seeing the slope of AB is 1/2. I'm looking at my picture, does that make sense? Up 1 over 2, up 1 over 2, that looks about right. Okay, what was the midpoint of AB? What location is going to split this segment exactly in half? Yeah. 3, -1, 1, 2, 3, -1. Agree with that? Looks like it would work. 3, -1. Okay, so now when I try and write the equation of the perpendicular bisector, is this the slope I want to use and the point I want it to go through? Now if I use the same slope, wouldn't it create something that's slanted the same way? To be a perpendicular bisector, I've got to slant it the opposite reciprocal direction. So what slope should I use? Opposite sign and reciprocal, -2. So the perpendicular slope is -2 over 1, which is just -2. So to write the equation, you need to do the midpoint and this slope. And again, let's start with point slope. Y minus -1 equals -2, parenthesis, x minus 3. Y plus 1. Distribute over here, -2x plus 6, -1, -1, y equals -2x plus 5. Let's see if that makes sense over here. +5, 1, 2, 3, 4, 5. Okay, so it goes through there, but it has a slope that's down 2 over 1, down 2 over 1, down 2 over 1. What did we say that point was going to be? Midpoint, 3, -1. So here's my perpendicular bisector to go through that segment. Question? Let's try another one then. Probably have time for one more to get squeezed in here. I have a worksheet for you for your homework. So let's do, again, equation of the perpendicular bisector. -3/2 for the slope to make it a perpendicular. Let's see what, you can see if I did the right. Does that match up with what you had? Y equals -3/2 x plus 12.5. Get that last number to come up right? Yeah? Good. Okay, you've got the slope of 2/3. Did you do that to start with? Okay, 2/3, and we're gonna turn it into -3/2. So you're at this point, -3/2, you've got the 9 on the negative one to put in, that was y plus 1. Okay, then where did I get this number? And I distributed -3/2 times -9 over 1, would be positive 27 over 2. 27 divided by 2 should be 13 and a half. So that's where this number came from. Then I subtracted 1 to get the 12.5. Thumbs up or down? Okay, so looking at the worksheet, it starts out reviewing your different forms, just identifying which ones they are. The front side, notice is what we were doing. On problem 7, let's do 8. 8's a quick one. 8 says, write the equation of the line that has that slope and through that point in point slope form. So what's number 8's answer going to be?